Water is tighter, energy is pricier, and yields still have to rise. Today's irrigation isn't about soaking, it's about precision. The goal has changed: deliver the right dose, in the right place, at the right time, with minimal loss. That's how you clean water is precious. But in many irrigation systems, a significant share never reaches the roots. Hidden leaks, outdated schedules, guesswork that floods fields without feeding growth. Every lost liter is money, and time, you don't get back. If everything is off, but your water meter is still spinning, one thing is certain: water is going somewhere you didn't plan. That slow tick usually means a hidden leak, a stuck valve, or a line that's cracked just enough to weep all day. And every tick is money, plus lost pressure that makes the rest of your system underperform. If everything is off, but your water meter is still spinning, one thing is certain: water is going somewhere you didn't plan. That slow tick usually means a hidden leak, a stuck valve, or a line that's cracked just enough to weep all day. And every tick is money, plus lost pressure that makes the rest of your system underperform. Finally, the problem is clear: hidden leaks, manual rounds, uneven watering, wasted energy. Every meter spin without a valve open is money down the drain. Hours disappear walking fields while crops still don't get what they need. Some zones drown, others thirst, and yields pay the price. Pumps push when pressure isn't needed, burning cash and power. Data is scattered, audits are slow, decisions arrive too late. We can't fix what we can't see. Visibility is the first step. Burning cash and power. Data is scattered, audits are slow, decisions arrive too late. We can't fix what we can't see. Visibility is the first step. Then control, automate valves, match pumps to demand, stop waste at the source. Give farmers proof, not guesses, flow, pressure, and alerts that matter. Because every drop counts, every minute counts, and every season counts. So let's end the leaks. What is SWCFB1 and how does it really work? Think of SWCFB1 as a solar-powered field brain for irrigation. It sits beside your manifold, connects to the sensors, valves, and pump relay you already use, and turns raw readings into decisions, automatically. First, it senses. Flow meters and pressure transducers are the truth tellers. They show exactly how water is moving through each zone. Add optional soil moisture and weather inputs and the picture gets richer, not just how much water moved, but how much water was needed. Second, it learns. SWCFB1 builds a profile for each zone, its typical flow, pressure, and runtime at different times of day and crop stages. A lightweight on-device AI model watches for anomalies. For example, this zone usually stabilizes at 1.8 bar in 20 seconds. Today it's falling to 1.2. When something looks off, the system raises the flag immediately. Third, it acts. Based on rules you set, and the patterns it learns.
Today I am excited to present our project on a solar-powered water management system. This project focuses on using renewable energy, specifically solar power, to efficiently manage water distribution in a sustainable and environmentally friendly way. Water is one of the most important resources on our planet. It is essential for agriculture, industry, ecosystems, and everyday human life. However, managing water efficiently has become a major challenge, especially in regions where electricity supply is unreliable, or where energy costs are high. Many water systems depend heavily on traditional electricity sources, which can be expensive and harmful to the environment. This is where renewable energy solutions come in. Solar energy is one of the most abundant and clean energy sources available to us. By harnessing sunlight and converting it into electricity, we can power different systems without relying on fossil fuels or complex power infrastructure. Our project combines solar power generation with smart water management technology. The main goal is to create a system that can generate its own power using solar panels, and use that energy to operate water pumps, monitoring devices, and control units. In this video, I will explain how the system works, how the solar energy is generated, how the energy is stored and managed, and how the system controls water distribution efficiently. Let us start by looking at the main component of the system, the solar panel. The solar panel is located at the top of the structure. It is positioned at an angle to capture maximum sunlight throughout the day. Solar panels are made up of photovoltaic cells, which are designed to convert sunlight directly into electricity. When sunlight hits the surface of these cells, it excites electrons inside the semiconductor material. This movement of electrons generates an electric current. The electricity produced by the solar panel is in the form of direct current, also known as DC power. This DC electricity becomes the primary energy source for the entire system. Since the panel continuously receives sunlight during the day, it generates electricity that can be used immediately or stored for later use. One of the advantages of using solar panels is that they are highly reliable and require minimal maintenance. Once installed, they can operate for many years while continuously producing clean energy. The next part of the system is the Energy Control and Management Unit, which is located inside the base structure beneath the solar panel. This unit is responsible for regulating and distributing the electricity generated